Hi guys. Okay, so today we'll do this figure, and the question reads: the uniform 120 Newton board is supported by two ropes as shown. A 400 Newton weight is suspended 1/4 of the way from the left end. Find the angle theta made by the left rope and find F1, F2. Okay, so first we'll start with our data. We're dealing with static equilibrium, therefore summation of forces is equals to 0. Then we also know in this case that the torque should also be equal to 0. Then we are being asked to find theta. We're also being asked to find F1, Ft1, and Ft2. Okay, so this is Ft1 and this is Ft2 and this is Ft1. All right. So what we have here, right, is four forces: the weight, which is 120 newtons, Ft1, Ft2, Ft1, and 400 newtons. So we are going to break them into components. So we'll say the vector. We'll start with Ft1, then its x component. So in this case, you can go about it two ways. You can pick this so that you pick this angle as 30 degrees, but for simplicity's sake, I'll be taking that so that Ft1 is my hypotenuse. Okay, and also in this case, I'll take this to be my triangles. Okay, so we'll therefore say Ft1. So this will be equal to Ft1 sine theta, sine 30 degrees. Then this will be Ft1 cos 30 degrees. Okay, so in the x we have Ft1 sine 30 degrees. In the y we have Ft1 sine 30 degrees, of course, cos 30 degrees. Then for Ft2 we have Ft2 also here sine theta, Ft2 cos theta. Then the vector for 100 newtons be given by, if we look at the direction, this is in a negative direction, it would be 0 in the x and negative 400 in the y. For the 120 newton, we are going to have 0 in the x and negative 120 in the y. Okay, so after finding the components, we can now say solutions. Then we are dealing with something in static equilibrium. Therefore, we'll use the concepts of summation of forces should be equal to 0, which implies that summation of forces in the x is equals to 0 and summation of forces in the y is also equal to 0. We'll first start with summation of forces. Summation of forces in the x, which is equals to 0, we imply that we have two forces acting in the x direction, which is Ft1 sine 30 degrees. Both are in the positive. Ft1 is in the positive direction. If we look at this is going in that direction. Therefore, this is in that direction. That force in that direction, the component. the component for ft2 is in that direction, then this in that direction. Therefore, ft1 sine 30 degrees is positive, while ft2 sine theta is negative. So this is in a negative direction. This should give me 0. So we'll therefore say ft2, if we add it on both sides of the direction of the equation, we'll find ft2 theta is equals to ft1 sine 30. Okay, let's name this as equation 1. Then summation of forces in the y should be equal to 0, which implies that we get those values. We have negative 400 minus 120 plus ft2 cos theta plus ft1 cos 30 should be equal to 0. Therefore, ft2 cos theta is equals to, if I add these two, I'll get 520. Then if we subtract ft1 cos 30 on both sides, we'll get ft1 cos 30 degrees. Okay, let's name this as equation 2. Then we'll also now deal with torque. So when you're dealing with the torque, summation of torque, it should also be equal to 0, which implies that at this point you get to choose your pivot. So the best way to do it is choose a pivot that will simplify your equation. So for me, I'll pick this as my pivot so that I eliminate this unknown and also that unknown, so that I only remain with one unknown. Okay, so if this is my pivot, I now get this having a torque, this also, and the ft1 in the y direction. So this implies that my torque will be 400 newtons in a negative direction. Then its distance from the pivot, they said it's 1/4. So it's 1/4 of the length of the bar, which is, we'll let L be the length of the bar from here to there, will be L. So 1/4, which is L over 4, minus 120, which is 2, which is L over 2. It's half of L. Then plus this force is in the positive direction, this one. So we'll say ft1 cos 30 degrees multiplied by L. This should give me 0. So this gives me negative 100, and this gives me 60. Then all these are multiplied by L. Then I'll take this on both sides. I'll subtract ft1 cos 30 degrees L on both sides of the equation. I'll get ft1 cos 30 degrees multiplied by L. Then just multiply both sides by a negative. We'll find those two will cancel and they will remain with positive. So therefore, it will remain with ft1 cos 30 degrees is equals to 1/60. Then we'll say ft1 is equals to 1/60 over cos 30. Then we'll get our calculators and say 1/60 divided by cos 30. and it gives me 184.75 newtons. So that's my FT1. Then from there, we are going to now solve for theta and FT2, since those are the two variables we don't know. So we are going to come back to equation 1 and equation 2. So equation 1 will say, from equation 1 we had ft2 sine theta is equals to ft1 sine 30. So we'll substitute the value for ft1. ft2 sine theta is equals to 184.75 sine 30. Again, on our calculator, we say 184.75 sine 30, which gives me ft2 sine theta equal to 92.375. Okay, then from here we'll go to equation 2. We have equation 2 was given by ft2 cos theta is equals to 520 minus ft1 cos 30. We'll substitute for ft1 cos theta is equals to 520 minus 184.75 cos 30. Then on my calculator, I punch in also that. We'll say 520 minus 184.75 cos 30. And we'll get ft2 cos theta equals to 360. Okay, now from here we are going to manipulate these two equations. We know from trigonometry that tan is equals to sine over cos. So we will therefore say ft2 sine theta over ft2 cos theta is equals to, our value there is 92.375 over 360. So this will give us tan theta. Okay, so in case you are wondering why these f2t cancel, they'll cancel each other. Then we understand saying, let's give an example saying if we have 2 over 3, if we divide that, it gives us 0.666. This is the same concept if we had 8 over 12, right? It also gives us 0.666, because if we factor out 4 over 4 and we remain with 2 over 3, this will cancel out to give us 0.6667. So the same concept applies here. We can cancel out that, but the fraction this gives us, the answer, should be equal to sine theta over cos theta. So we'll say tan theta is equals to 92.375 divided by 360. It gives me 0.25659.722. Then we'll say theta is equals to tan inverse of 0.2565972, which we'll punch in our calculator, and this gives us theta equal to 14.39 degrees. Okay, then from here we are now looking for F2. So for F2 we can actually even use this equation. So we'll say ft2 sine, our theta has been found to 14.39 is equals to 2.375, which means ft2 is equals to 2.375 over sine 14.39. This should be equal to 92.375 divided by sine 14.39, which gives me 371.6, we'll just say 699 newtons. Okay, that's the end of the question.